Hello everyone and welcome back to the YouTube channel of Gamaka AI. I welcome you all to the Power BI series. In the today's video, we are focusing on what data modeling is. See, your data might not be stored in a single table. Your data might be scattered across multiple different tables, right? And the process of connecting these different tables together based on some common column with each other is called as a data modeling. And a well-designed data model makes your data clean, organized, and powerful for the data analysis and the reporting. Let's see what is a denormalization. Denormalization means storing all your data all together into a single table, even if some value repeats. You can refer to this screenshot that I have attached of a table over here. Denormalization comes up with the advantages and the disadvantages too. What are the advantage of the denormalization is it is faster for the reading and reporting as your all data is stored in a single table. But it has some limitations or you can say the disadvantages like data duplication is there. This particular table will require the large amount of the storage and it is difficult to make the updates into this particular table. For example, imagine a sales table where customer name, product names and order details all are repeated into one giant table. Let us move forward with the normalization. So, to overcome the disadvantages of denormalization, we come up with this concept called normalization. So, what is a normalization then? It is nothing but you will divide that one giant table across multiple tables. And how that process is called as the normalization. Means you will split your data into multiple related tables just to avoid the redundancy. So the advantage of this normalization of the data would be there will be the no duplicate data stored across different tables and it is easier to make updates and it is easier to maintain as well. For example, instead of repeating multiple customer name into a single table, you will have a dedicated table for the customers and you can connect it to your orders table very easily, right? So the same table, one giant table, I have divided into multiple four tables. So this is a table dedicated to orders information, table dedicated to customers related information, table dedicated to products and the date related information. So this is what the concept of normalization is. Now let us look at what is a fact table and what are the dimension tables. The fact table is a table which will store the measurable or you can say the quantitative or the numerical type of data. For example, sales amount or the order quantity or the profits or the discount. It usually contains the foreign keys that connect to the dimension tables. Now this is one example of the fact table. Now let us understand what are these dimension tables. Dimension table is a table which will store the descriptive or you can say the categorical or you can say the textual type of data. For example, customers details, product names, cities or the dates. And this particular tables, dimension table, they usually contain primary keys. Now let's understand what are the primary and the foreign keys. So primary key is nothing but a unique column or it can be the combination of columns as well, but it will help you to identify each row in a table uniquely, and that's what primary key is. For example, this is a table called dim customers and this customer table is having the customer ID as a primary key because if I know particular customer ID, I can fetch out its name and its city where that particular customer belongs, right? So the customer ID in your dim customers table will become the primary key. Now there comes the foreign key. What is a foreign key? Foreign key is a column which refers to the primary key of another table. For example, there is one table called fact orders over here. So this table is having this column called customer ID. But this customer ID column is a foreign key over here. Why? Because customer ID is already the primary key of my dim customers table. And how can you connect these two tables with each other using this customer ID? Why so? Because the customer ID is the common column between both the tables. And why do we have to connect them? Because if I want to understand what is the name of this particular customer, so that information is stored in this table, right? That's why I have to connect these two tables to each other. And this primary and the foreign keys will help you out with that. Now let us understand what are the schemas in the data modeling. So schemas are nothing but a structures or you can say the logical structures which help you define how this fact and the dimension tables are connected to each other. So there are three types of schemas. First one is a star schema, second one is a snowflake and third one is a galaxy schema. So let us look at each and every schema one by one. So the star schema is nothing but it will be having a single fact table which will be surrounded by dimension table. Now you know what is a fact table, what is a dimension table. Over here this orange color indicate that it is a fact table and the blue color indicating it is a dimension table. So on the left side you will be able to see a logical representation of this star schema, and on the right side I have added one example, real life example, how these tables are connected. For example, this is a fact sales table which is connected to the date, store and the product dimensions. Why do we call it as a star schema? Because it looks like a star when visualized. When you can use this type of schema, so it is best for simple reporting dashboards or the reports. Then let's move forward and see what is a snowflake schema. So a snowflake schema is nothing but it will be having a single fact table, and that table will be surrounded by the dimension table same as that of the star schema. But these dimension tables will be further normalized into another dimension tables. Okay. And why do we call it as a snowflake schema? Because it looks like a snowflake. So on the left side, you will be able to see the logical representation of it. And on the right side, you will be able to see one real life example of the snowflake schema. So over here fact cells is my fact table, and that fact table is surrounded by multiple dimension tables, and these dimension tables are further normalized into other dimension table. Let's say this product table is further normalized into the brand of the product and the product category. Likewise. So this particular snowflake schema is best for the complex data warehouses with the multiple hierarchies where the storage optimization and the reduced redundancy matters. Let's move forward and see what is the galaxy schema then. So galaxy schema is a schema where multiple fact tables are involved, and these multiple fact tables are sharing some common dimension tables. This galaxy schema is also called as a fact constellation schema. When you can use it is, it is best for the large enterprises system which is having multiple business processes that share the common dimensions. For example, on the left side over here at the top you will be able to see the logical representation of the galaxy schema, and at the bottom you will be able to see one example. So in this particular example, these two fact tables called as a placement and the workshop, these two fact tables are sharing the common dimension called as a student and the TPO. TPOs are nothing but training and placement officers. So in this particular case you can go for the galaxy schema. Now let us understand the important concept while creating the relationship between the tables, and that concept is called as a cardinality. So what does the cardinality means? Cardinality is nothing but the uniqueness of the values in each and every column. It lets you know how many unique values are there in the given column. There are four types of the cardinality. The first one being one to one, the next one is one to many, the third one is many to many, which is just the opposite of one to many, and the last one is many to many. So let us understand, and I will also give you the real life examples of this cardinality. So let's try to focus on one to one. So what can be the examples of one-to-one cardinality is each employee can have exactly one ID card, right? Another example could be each country has one capital city. Then let's move forward with the one-to-many cardinality. So what can be the examples of this particular case is one customer can place multiple orders, right? And one teacher can teach multiple students. Then there come many to one cardinality. So what can be the examples of many to one cardinality? Many employees can work in a single department, or many books can be published by a single publisher. Then there comes another cardinality type which is many to many, and the examples for that could be students can enroll in multiple courses and each course can have multiple students, or products can have multiple stores and each store sell multiple products. So these are the examples of the different type of cardinality, and in the Power BI most commonly used cardinality is one to many, or you can say many to one is just opposite of one to many, and you have to strictly avoid this many to many cardinality in your Power BI. And that's complete breakdown of data modeling in Power BI. Thank you for watching till here, and I will see you in the next one.